X denote the rectangular, and let Y denote the cylindrical. So it tells us what they want us to use for X and what they want it to use for Y. So again, coming back to these constraints, these or again, these limitations. Somehow the inequalities, what we graph and shade, that's limiting something in the word problem. Okay, so just based off of what we've read so far, what do you think those two constraints or those two limitations are going to be about? Joe? What are the two? Do what?
The amount of crates.
Not the amount of crates. What are the two pieces of information they give us about each kind of crate?
The shape.
Not necessarily the shape.
Volume.
The volume. Okay, so one constraint is probably going to be about the space that they take up. And what else? The weight. So going to number 1, it says what constraint must be satisfied if each truck has room for at most 4,200 cubic feet. So that is the volume. Okay. If at most there is 4,200 feet, is it okay if a truck carries less than that?
Yes.
Would that still work? Yes. Is it okay if it is right at 4,200 feet? Can it be more than that? No. So whatever we put on the left side, it's going to have to be less than or equal to 4,200. Okay. How much space does a rectangular take up? 100. A cylindrical? There we go. Again, I talked about this a lot on the last unit. Once you use a piece of information, do not use it again. We just used the 100 cubic feet, 200 cubic feet. Now this one's a little tricky because 100 is in the word problem twice and 200 is in there twice. But know which 100 we're using and which 200 we're using. The next constraint that has to be satisfied said each truck can carry a maximum of 4,800. Is it okay if it weighs less than that? Is it okay if it is right at 4,800? But it cannot be more than. How much does a rectangular weigh? 200. How much does a cylindrical weigh? Okay, so on 3 says what additional constraints must be satisfied because the problem involves real objects. These are the two constraints that if you hear me refer to them as real world constraints, this is what I'm talking about. The problem's talking about different kinds of crates. Is it possible for you to have a negative number of crates? No. So both X needs to be greater than or equal to 0, and Y needs to be greater than or equal to 0. Alright, come quiz time or test time, if you're asked to write the constraints, and it is a word problem, write those first. They're always going to be there. If it's talking about something that you cannot have negative of, write those in there, because that's probably, if it's 2 points per equation, per constraint, that's 4 points right there. One for X is greater than 0, one for Y is greater than 0. So let's go through here and graph our constraints. So first I'm going to do my x-intercept, which means I'm going to completely disregard that 200y. So if it's 100x equals 4200, what is my x-intercept? 42. For my y-intercept, I'm going to completely disregard the x, the 100x, And so then what is 4,200 divided by 200? 21. Now, as you can tell, the graph that they gave us on this, it does not have 42 increments, so we need to count by something different than that. Each one is going to be 4. If you cannot see what these are in the back, please let me know and I can help, but they're just going by 4s. Okay? And then I skip each one, so that's just kind of an easy way so you don't have to sit there and write a number underneath each line. So on the bottom it's 4, 12, 20, 28, 36, 44, 52. Can't see it. After that, let's graph these. And be careful whenever you're graphing these. Especially whenever it doesn't fall right on one of those numbers or right on a line. So I've got 42. So 36, 44, which means right there is 40. So it will be halfway in between those two. And I have 21, 0. Okay, so here's 20. This is 24. Right in the middle is 22. So it's about a quarter of a unit above 20. It would roughly be right there. Alright, so take that second one off. It should be between those two. Okay, so going up, getting the x and y intercepts for the next. For the next one, so for my x-intercept, disregard the 100y. 4,800 divided by 200 is what? 24. Then I would disregard the 200x. 4,800 divided by 100 is 48. These are a little bit easier to figure out. 48 is going to be at the very top left corner. And then 24 is the one between 20 and 28. Your real world constraints, you don't really have to graph them, because most of the problems that you'll be given, you're only given the first quadrant of the full graph, so that's all they're saying. It's almost like they're already on there. So both of these are less than, so am I going to shade above or below the lines? Above. 0.21. Morgan, what's another one? Okay. Now let's talk about 0, 0. 0, 0, technically it is 1. Whenever you're going to have a problem that's going to try to maximize something, that is never going to be the answer. Because you would plug 0 in for x, you'd plug 0 in for y, it cancels everything out. You'd always get 0. Okay, so you can plug that in and do the work if you want. I would not. Okay, so Morgan, give me another one. 24, 0. And the one that is out in the graph, let's use 18, 12.
That's kind of confusing. Like, what if you like mess up like by one and the whole entire answer's wrong?
Yes.
So, why are we doing this?
Do what?
Why are we doing it by
I don't know if you want me to say this, I'm gonna say it.
Coming down here to number 5, it says, so this is where we're going to get the objective function. It says, suppose the Supreme shipping charges $50 for each rectangular and $60 for each cylindrical. And they wish to maximize the income. Your objective function is always going to start with what? P. And then they get $50 for every rectangular crate. What variable represents the rectangular crates? X. So $50 times however many rectangular crates, and then $60 times however many cylindrical. So we need to plug each vertices that we found into that objective function and see what it gives us. Alright, Garrett, whenever you put 0, 21 in, what did you get? 1,260. Gracie, whenever you put 24, 0 in, what'd you get? And Zoe, whenever you put 18, 12 in, what'd you get?
1,620.
Okay. So, bear with me for just a second. Let me copy all this so I can scroll down. And then put it back on there to answer this question. Okay. So, to answer E, it says what combination of containers would they use? So, Ms. Williams, what combination should they use to maximize their profit?
C.
Okay. So I put that as my answer, and I'll get it right. Vertex C is what?
18, 12.
Okay. 18, what kind of crates? 18 rectangular, 18?
Rectangular.
18 rectangular. Make sure that on problems like this, you put what that is. Does everyone see how we got that?
Can you just put the max in?
Yep, they're trying to maximize, so 1620 was my max. Okay, we got that point from 1812. And you need to know that the X's were the rectangular, the Y's were the cylindrical. Now listen, come CBA time. If this was a question on the CBA, I can all but guarantee that one answer choice would obviously be this one, and another one would be 18 cylindrical and 12 rectangular. So you need to know what the variables represent. Because they like to do that on those tests.